babies? How we doing? Welcome to our last video lesson for chapter 9. Today we're going to put everything together. Our end result today is going to be solving right triangles, meaning our goal is to be able to find all the angles and sides of a right triangle, given some of the things we've talked about the last couple weeks, such as Pythagorean Theorem, sine, cosine, and tangent ratios. So before we do our examples on solving right triangles, we're going to go through kind of the last thing using the trig ratios, and that's what's called the inverse trig ratios. So the inverse trig ratios are used, and I guess thinking back to what the word inverse means, inverse is a way of saying opposite. So the inverse trig ratios are used to do the opposite of what the trig ratios do. Now, the trig ratio, as we learned, there's three of them: sine, cosine, and tangent. So if I were to just choose sine, for example, what the sine does is it relates the angle of that triangle to two sides, the opposite side and the hypotenuse. And again, what this does, what the sine does, is it relates the angle, okay, and what's going to do is it's going to give you a percent. So for example, if I said, let's say the sine of 30 degrees. The sine of 30 degrees, if I were to punch that into a calculator, would give me 0.50. Think of that again as 50%. So what the inverse sine, cosine, and tangent are going to do is that reverse process. We're going to take the percent. So we're going to start here with our percent, and our goal is to work backwards and try and figure out what the angle is. So again, what these inverse trig ratios are going to do is it's going to relate the ratio of the two sides. So whether it's opposite to hypotenuse, adjacent to hypotenuse, or opposite to adjacent, and it's going to relate those two sides back to the angle. So given the sides, we are now have a way, by using the inverse of these functions, by using the side lengths, we will now have a means to find the angle based on the side lengths. So it's kind of working backwards, but it's now a way in which we can relate the lengths of the sides to the angles. So here's how these are going to be written, okay? So it's going to look a little bit different. So if, again, all of these are going to be used to find the angle, and again, the symbol we use for angle is that Greek letter theta. So inverse tan, you're going to still see tan, but to represent the inverse, you're going to see a -1 written on top. This -1 is the fancy math way. So that -1 right there is the fancy math way of saying inverse. And inverse means opposite, okay? So you'll see tan -1. You'll see sine -1. You'll see cosine -1. And what it's going to do is it's going to relate, again, the percentage you're going to get from here for tangent, the opposite over the adjacent. For sine, it's going to relate the opposite over the hypotenuse. And for cosine, it would relate the adjacent over the hypotenuse. And again, what it's going to do is work backwards, okay? We are going to figure out what the decimal is, and using these inverse trig ratios, it's going to tell us what the angle is. So let's go ahead and do our first example. So let's say that the tangent of A is 0.75. Now the tangent, again, is going to relate the opposite side of a right triangle to the adjacent side. So what this is saying is that if I were to relate these two sides, what I'm getting is 0.75. Okay? So what I want to do is I want to know what is the angle that would create that decimal. So what would create the decimal of 0.75? So to do this, what I'm going to do is to find the angle A, all I'm going to do is take the inverse tangent, so tangent with that -1, of that decimal of 0.75. And all I got to do is I have to plug that into the calculator. Now, on your calculators, depending on if you're using a calculator or using that Desmos app, and again, I'm going to show you guys how to work with that. But you're going to see this normally written right above sine, cosine, and tangent. So if you were to be using a calculator, you would have the tangent button, and usually written above it, you'll see tan -1. Okay? So that means you would have to hit second, and then whatever trig ratio we're using, sine, cosine, or tangent, you'll see that -1 pop up. It'll be tan -1, and normally there will be a parentheses that you have to fill something in. So then whatever you have to fill in is what you would plug into the parentheses. Okay, so our goal is, again, when we type this into our calculator, it's going to give us the angle. Now for simplicity, we're going to round this to a whole number. So what I get is 36.5 0.87, and that's rounded. So what we're going to do is we're going to round this to a whole number of degrees. And be careful again on big ideas what it asks you to round to, but we're going to round this to 37 degrees, okay? Now kind of drawing this out, what does this look like? I know I got a lot of stuff going on here, but here's what this says. If my opposite side, let's say I'm trying to find this angle right here in the corner. If my opposite side and my adjacent side, if I were to relate the opposite divided by the adjacent, if I get 0.75, what that means is that the angle that's created in there would be a 37 degree angle. That a 37 degree angle would create that ratio of 0.75. So we're kind of working backwards here. So ideally what you want to do is whatever the trig ratio that you have set up, you want to use the inverse sine, cosine, or tangent. All right, next example, we have sine of b equals 0.87. So our goal is to find angle b. So to find angle b, since we have sine, to find the angle, we're going to use the inverse sine of that decimal 0.87. So in our calculator, we would type in inverse sine, we would type in that decimal, and then we're going to get our angle, and we're going to round this to the whole degree. So we're going to get about 60 degrees here. So 60 degree angle would create that decimal or that percentage. All right, last one here for C, it says cosine of C equals 0.15. So if I want to find angle C, I'm going to do the inverse cosine. And again, think of that 0.15 as 15%. That relates the adjacent to the hypotenuse. So if I were to get 15%, the inverse cosine is going to tell me what angle creates that. And by rounding here, you should get about 81 degrees. 81 degrees. Okay, so this is the last piece of the puzzle. And again, how this is useful, inverse sine, cosine, or tangent, is going to be useful to find the angles if we know the side lengths. All right, so our goal in using sine, cosine, tangent, the inverse sine, cosine, tangent, is to be able to find side lengths and the degrees of angles. And the whole idea of this chapter is being able to relate the angles in degrees and the side lengths. So our goal really in this last section is to be able to solve a right triangle. When I say solve, our goal is to find everything. I want to know what are the lengths of all three sides. What's the length of B to C? What's the length of C to A? What's the length of A to B? Okay, so I want to know what are these three lengths, A to B, B to C, and we'll say C to A. I also want to know all the angles. Okay, so what would angle A, whoopsie daisies, what would angle A equal in terms of degrees? What would angle B equal? What would angle C equal? I'll put the little M there so we know we're talking about the measure. But I want to know what are all three side lengths equal to and what do all three angles equal. So to do this, we're going to use all the tricks and trades we learned about within this chapter. Okay, so right away, I know side lengths. I know that based on my diagram that B to C, we already know that this is a length of 3. I know that C to A is a length of 2. So I do need to figure out what the length of A to B is. Now to find the length of A to B, we can go back to section 9.1 and we can think about using Pythagorean Theorem. Okay, Pythagorean Theorem is going to relate all three sides of a right triangle. If you remember, it is A squared plus B squared is going to equal C squared, where A and B are the two legs and C is the hypotenuse. So what I want you to notice first is that notice that C is going to be the hypotenuse of this triangle. Sorry, what's labeled as C, well, we're going to write down as A to B because it's across from the 90 degrees. So what I'm going to do is I'm going to use Pythagorean Theorem. If A squared plus B squared equals C squared, then if I plug in those values, so I know that the smallest side is 2, I know that the middle side is 3, so again, I'm squaring those. My goal is to find C, okay? And C is that third side of the hypotenuse. So I know that 2 squared is 4, 3 squared is 9. If I add those two things together, I'm going to get 13. So again, to find C, what I'm going to do is take the square root of that side 13. And that's going to tell me then that that third side is going to be the square root of 13, which as a decimal is going to give you about 3.6, but we're going to leave it as an exact answer. So I'm just going to leave it as square root of 13. Just know again that as a length, that's going to be 3.6, but we're going to use that value of square root of 13. So now what I know is I know all three sides of this right triangle. But my goal is also to figure out what are the three angles, okay? So I want to know what is angle B, what is angle A, and what is angle C. Now right away I do know that angle C is going to be 90 degrees. Okay, so my goal is to figure out what A and B are, and this is where the inverse trig ratios are going to help. If I want to find A or B, I have to relate those angles to the side lengths. Okay, so for example, let's say we want to find angle A. So angle A is right here. So know that the two sides you are given is 3 and 2. Okay, so what I'm going to do is I'm going to relate A to those two sides. I know that A, based on those two sides, that 3 is going to be the opposite side and 2 is the adjacent side. So I'll put a little O and a little A there. So if I'm relating the opposite side and the adjacent side, that means I want to use the tangent. So I know that the tangent of angle A is going to relate the opposite to the adjacent. So that would be 3 divided by 2. Now, 3 divided by 2, if I were to divide those out, is 1.5. Now, why am I writing this out like this? Okay, this is how it's going to relate back to what we did last example. I have the tangent of A equals 1.5. So I want to know what angle for A would give me that ratio of 1.5, that percentage. Think of it as 150%. So to find A, what I'm going to do is take the inverse tangent of 1.5, and it's going to tell me the number of degrees I would have for angle A. By plugging in my calculator, it's going to tell me that A is going to be about 56 degrees. So A here is going to equal 56 degrees, and I'm just going to place it up here, 56 degrees. Okay? Now, to find angle B, I have a bunch of different options. Again, what I can do is relate angle B to the two side lengths, 2 and 3. But there's an easier way. What we know right now is I know that one of the angles, C, is 90 degrees. I know that the other angle, A, is 56 degrees. So if I want to find the third angle, what I know is that all three of these angles have to add up to 180 degrees. So if I know 2 of the 3 already, what I just have to do is take 90 and 56, and I would add those two angles together, and that's going to figure out how many degrees I have so far. These two would add up to 146 degrees. So to find the third angle, I'm just going to take that 146 and subtract it from 180. So I'll just jot that down here. I'm going to take 146 and subtract it from 180, and that's going to give me 34 degrees. So I know that angle B is going to be 34 degrees. So what I have now done is I have now solved this right triangle. I now know all 3 side lengths, and I now know all 3 angles. What I had to do was I had to use Pythagorean Theorem and a little bit of the trig ratios to solve for those things. So this is why it's called solving a right triangle, because we're trying to figure out all the meat and potatoes, all the information involved. All right, let's try our next example. Just going to slide all this meat and potatoes over so we have some more real estate here. But again, our goal is to find all 3 sides and angles, so I'll just jot this down. So I have triangle DEF, so we're going to try and find DE, EF, and FD as our 3 sides. Okay, so writing down what I know, I already know that E to F is 21. I know that F to D is 20. So I obviously have to find what D to E is. So if we want to right away, we can use here Pythagorean Theorem. I know that, again, F right here is my 90 degrees, so I know that D to E is the hypotenuse. So why that's important is that when I use Pythagorean Theorem, I'm going to take 20 squared plus 21 squared, and that's going to equal C squared. So this is A, this is our B, and our goal is to solve for C. Okay? So taking 20 squared, I'm going to get 400. 21 squared, I would get 441. That's fun. And then I have C squared, which I'm going to find. So what I'm going to do is take 20 squared, which was 400, and I'm going to add that 441 together. And here's I'm going to get 841, and then equals C squared. And the last thing I got to do here is square root that to find what that last side is going to be. In this case, I'm going to get a nice clean number, and it's going to tell me that C, that last side, is 29. So voila, I now know this side is 29. So I now know all 3 sides. Next thing I need to do is find all 3 angles. So I want to find the measure of angle D. Whoopsie daisy, sorry folks. That's not my angle symbol. So the measure of angle D. I want to find the measure of angle E, and I want to find the measure of angle F. Okay? Based on what I'm showing here, again, angle F, right there, you see the box. So I know that angle F is going to be 90 degrees. So my goal is to find angle D and angle E. And just like the last problem, what I'm going to use are my trig ratios. So again, if I want to find, let's say, angle D, well, relating the two sides, 21 would be the opposite side. Okay, so let me just draw some arrows here. 21 is the opposite side, and 20 would be the adjacent side. So if I want to find the angle, what I'm going to use, what relates opposite and adjacent, is tangent. That the tangent of D is going to equal, again, the opposite over the adjacent. So the opposite would be 21. The adjacent is 20. So that means the tangent of D is going to equal, and what I want to do is take and divide 21 by 20. So if I take 21 and divide it by 20, I'm going to get a decimal, in this case, of 1.05. So to find D, I'm going to do the inverse tangent. I'm going to take that ratio and now find the angle measure of that angle D. In this case, by rounding to a whole number here, I would get D is 46 degrees. So there we go, 46 degrees. And then again, to find that third angle, I know that all three of these should add up to 180 degrees. So if I just simply take 46 and add it to 90, so 46 plus 90 is going to give you how many degrees you have right now, which would be 136. So I'm going to take 180 minus 136, and that would tell me what I have for my last angle. In this case is going to be 44 degrees. So again, if you were to subtract what you have, that's how much you need to get to 180. So now I have solved again for all three angles, and I have solved for all three sides. Okay, so in this case, you were given some sides, and we had to find what was left over based off of that. All right, so we're going to do the same thing we just did. However, I'm just going to give you some different side lengths. So let's see that how it's going to affect Pythagorean Theorem and which trig ratio we're going to use. So you have triangle G, J, and H. So again, our first thing we're going to find is all three sides. So I know that G to J, okay, I want to find that. I want to find J to H, and then lastly, H to G. So what I know already is I know that J to H is 91. I know that G to H is 109, so that means I need to figure out what G to J is. Okay, so here's one difference about this problem. Based on what you're given in your diagram, here you have angle J, okay? So that means the side across from it's always the hypotenuse, so here you are given the hypotenuse. Your goal is to find one of the other two sides. So know that G to H, or H to G, this is my C. That means my other side, this is most likely B, and I'm trying to find A. So when I set up A squared plus B squared equals C squared, now what I'm trying to solve for is A. I know B is 91, and I know C is 109. So what I'm solving for is in a different order here. Okay, so A squared would come down. My 91 squared would give me 8,281, big number, don't be scared. And then 109, even bigger, holy strawberries, Batman, you get 11,881. Then to solve, what I would do is subtract this over. Again, this is what we did in 9.1. And that's going to give me, folks, nothing but 3,600. Know what I'm saying? So I'm going to bring down that A squared. And then lastly, to solve for A, I'm going to take the square root of both sides. And that's going to tell me that my remaining side A would be exactly 60. So I know that G to J is going to be a length of 60. Okay? So, good. Figured out all the sides. Now, again, what we want to do is figure out all the angles. So I want to find what is the measure of angle G, what is the measure of angle J, and what is the measure of angle H. So that is my goal, find all three sides, all three angles. All right, so we know based on the diagram that J is my 90-degree angle. Okay, that's labeled 90 degrees. So that means I want to find angle G and angle H. So again, the angles are the space between the lines. So I have these three angles here I'm trying to find. So we just can pick one. So let's say I want to find the first one, angle G. Angle G is right here. So based on what I'm given, I'm given 91. So based on how I'm drawing that from G, 91 is the opposite side. And we already know that 109 is the hypotenuse. So why it's important is we have to identify which trig ratio relates the opposite and the hypotenuse. In this case, it would be sine. The sine of angle G relates the opposite side to the hypotenuse. The opposite side is 91. The hypotenuse is 109. So if I want to find G, I know that the sine of G would relate 91 to 109. So I'm going to take these two numbers and divide them out. So 91 divided by 109, again, is going to give you a decimal. And that decimal is going to represent the percent. In this case, you're going to get about 0.83. Okay, so think of that as 83%. Sorry, 0.83. So if I want to find G, what I'm going to do is the inverse sine of that decimal 0.83. Okay, and then that is going to give me then my angle measure, which in this case is going to be about 56 degrees. So I know that angle G, I'm sorry, I run out of space, is 56 degrees. Okay, now we know angle G is 56, we know angle J is 90, so our goal is to find that third angle. So we all know, again, all angles should add up to 180, so that missing piece, we would just have to add 56 and 90 together, and then whatever we would get, we want to take that away from 180, and that would tell us our last angle, which in this case should be 34 degrees. So in this case, I just had to use the inverse sine instead of inverse tangent. It's just based upon the sides you are given. Okay. All right, now our last example here, baby shawties. Okay, I know this is a lot of meat and potatoes, so if you've got any questions at this point, just jot them down. But this last example here, babes, we're going to just solve a little bit differently. You'll notice here that I'm giving you guys one of the angles now is 25 degrees, and our goal is to find the missing sides. Okay, so our goal is to find the three sides again. So similar to last problem, we have G to H, we have J to H, and then lastly we have J to G that we're trying to find. Okay, based on my diagram, G to H you're given to you as 13, so we know one of the sides is 13, but here's the difference is that we do not know what the other two sides are. In the last problem, we knew two of the three sides. Now we only know one. Okay, so why it's important is at this point in time, we cannot use Pythagorean Theorem because we only know one of the three sides. You can only use this if you know two of the three sides. So before we do this, we need to know what some of the other side lengths are. Now to do that, we're going to use our angle here. Okay, so based on my angles, you have three angles. You have angle G, oopsies, angle H, and angle J. Okay, so based on the diagram, you know that angle H is 25 degrees. We know that angle J is 90 degrees. So notice the difference here. I know two of the three angles. So knowing that all three angles add up to 180 degrees, I can find this missing angle by just adding these two and figuring out the difference between, or difference from 180. So in here, you're going to get 115 degrees when you add those up. Sorry. So this would be 115 degrees. Subtract from 180, you're going to get 65 degrees. So right away here, I can solve for all three angles. So I'm done there. But now how do I take this information and solve for the side lengths? Well, this is where sine, cosine, and tangent are important. Okay, how do I relate angles to sides? I relate angles to sides by using sine, cosine, and tangent. That's the purpose of them. They relate the angles to the sides. So the angle you're given, obviously you're given 90. We don't want to use 90, but we're going to use 25. Okay, so if I use this angle, I am given right away, I can see based on my diagram that I'm given the hypotenuse of 13. Okay, so if this is 25, first of all, we can relate G to J, that side length, as the opposite side, that's the hypotenuse, and this is the adjacent side. So I have my options. I can choose either sine or cosine. Let's just use sine. So let's say here that I did the sine of 25 degrees. Now the sine of 25 degrees is going to relate the opposite side to the hypotenuse. Okay? The opposite side here would be H, and the hypotenuse is 13. So this is kind of going back to what we did in section 5. Here I know the angle, so I'm not doing the inverse. I'm just going to do the sine of 25. It's going to take that angle, break down to a percent. In this case, I'd get 0.42. So think of that as 42%. And that's going to equal H over 13. So when I say 42%, it's like saying, okay, what is 42% of 13? That's going to tell me what H is. So if I take 42% of 13, that's going to give me about, and it depends on how I round this, but rounding that, we're going to get around 5. So it comes out to 5.49, so we'll get 5 there just to make it easier on ourselves. So here we go on our diagram. H is G to J, or J to G, so we know that this side length here is going to be 5. Now here's the neat thing is that now I have 2 out of 3 sides here. So this is where I can use Pythagorean Theorem. G to J is the smallest of the sides, so that's A. J to H would be B, and we already said that G to H would be our hypotenuse, so that's C. So if I plug this in, I'm going to have 5 squared plus B squared equals 13 squared. 5 squared I know is 25. B squared we're trying to find. 13 I know is 169. Now to solve, if I just take 25 and subtract it over, whoopsie daisies, that's going to tell me B squared is equal to 144. But to solve B, remember what we got to do is square root both sides. So if I were to take the square root of 144, that's going to tell me B is going to equal 12. So that last side is 12. And notice here we have our Pythagorean triple of 5, 12, and 13. But again, what I did is just a little bit different order. I found the angles first, and then using the regular, not inverse, but the regular sine, I was able to find one of the sides, and then I was able to use Pythagorean theorem again. So there's a lot in this section, folks, because we are combining everything we've learned in these 3 sections to try and find sides and angles. And we also introduced that inverse sine, cosine, and tangent. So if you got any questions, make sure you jot those down. It's a little bit difficult, but you guys will have some time to work on those practice sets. So good luck, guys, and we'll see you next time.